Today we are going to talk about 9 different types of functions and their graphs. There are many different function types, but these 9 are some pretty common ones. So first we're going to talk about a constant function. So a constant function in function notation is f of x equals a, and a is just for a number. Okay? So not a variable, but some actual number. So for example, not in function notation, it would just say y equals, and maybe y equals 3. So that's a horizontal line, up 3. No matter what the x value is, the y value is 3. Okay, it's constant because the y value is a constant number. It is not changing. An identity function, f of x equals x, or y equals x, which means whatever the x value is, the y value is the same. So if x is 0, y is 0. If x is 1, y is 1. If x is 2, y is 2. And so on. So an identity function looks like this. A square function, f of x equals x squared. So it's a parabola. So if I have 0 squared, I've got 0 as my output, 1 squared is 1, 2 squared is 4, 3 squared is 9, that goes off the graph, but I'm still going to put a point there, approximately 1 off the graph, because otherwise I don't really know where I'm heading once I get past this point, so that just keeps me on the right track. Negative 1 squared, negative 2 squared, and negative 3 squared. So that square function graphs as a parabola. A cube function, f of x equals x cubed. 0 cubed is 0. 1 cubed is 1. 2 cubed is 8. Negative 1 cubed is negative 1. That third power, odd power, does not get rid of that negative. It's negative 1 times negative 1 times negative 1. Still have a negative in my output. Negative 2 cubed is negative 8. Now, just like the square function, and I didn't really say it up here, but it's a curve that we're graphing. So we need to make sure that it actually is a nice smooth curve. So on this cube function, we're going to do our best when we get toward this middle just to make a nice smooth curve. And I kind of missed my point up here, so I'm going to try that again. It's important to try to be precise as we do these graphs. Okay, so we'll be as precise as we can while we do these graphs. A square root function, f of x equals the square root of x. By the way, that's the same as x to the 1/2 power. Now, square root does not allow negatives underneath, so there will be no negative x's. So zeros and bigger. The square root of 0 is 0. The square root of 1 is 1. The square root of 2, it is a real number, but it's not an integer, so I'll continue. Square root of 3, no. Square root of 4 is 2. The next one is the square root of 9, which is off the graph, but if I want to know where I'm going, I need to graph it. Square root of 9 is 3, so I'm going to plot that approximately just to make sure that I keep going in the correct direction. So that is a square root function. An absolute value function, f of x equals the absolute value of x. The absolute value of 0 is 0. Absolute value of 1 is 1. The absolute value of negative 1 is also 1. The absolute value of 2 and negative 2 are both 2. So we can see a V shape forming. On the right side of this piecewise function here, we've got a slope of 1. On the left side, negative 1. A rational function. Rational with that root word ratio, it's a fraction. F of x equals a number over x. Okay, so for example, you could have y equals 4 over x. Okay, so if I use 0, 4 divided by 0, well that's undefined. So that means that the y-axis, where x is 0, we're never going to touch that with this graph. So that is going to be an asymptote. If I do 4 divided by 1, I get 4. 4 divided by 2 is 2. 4 divided by 4 is 1. That's not really enough to tell me everything I want to see, though. If I do 4 divided by 8, 4 over 8 is 1/2. And if I do 4 divided by 1/2, I get 8. That's going to give me a little better story here of what this graph should look like. Okay? But I can use negatives. I can't divide by 0, but I can divide by a negative. 4 divided by -1 is -4. Divided by -2 is -2. Divided by -4 is -1. 4 divided by -8 is -1/2. 4 divided by -1/2 is -8. So it reflects over y equals -x. And it looks like that. So as it goes off to the right, up, left, and down, it hugs the axis. An exponential function, f of x equals a number to the x power. So let's do an example of y equals 2 to the x power. So 2 to the 0 power, just like anything to the 0 power, is 1. 2 to the first power is 2. 2 to the second power is 4. 2 to the third power is 8. So you can see that with each interval to the right, it's getting steeper, going up faster. 2 to the -1 power. So 2 to the -1. If you remember your rules of exponents, I can move this to a denominator. So I'll put that over 1, and I can move that 2 down into the denominator, and it becomes a positive exponent, leaving me with 1 in the numerator and 2 in the denominator. So 2 to the -1 is 1/2. Okay, now I don't have the precision here to really do any closer to y equals 0 than that. So this graph looks like this, and y is never actually going to reach 0. It's going to hug that axis, and it's going to get infinitely close to 0. So the x-axis here, where y is 0, is an asymptote. A logarithmic function. For the purpose of what we're doing here, this one will be the least precise graph that we make. Log base b of x. So we can think of this in terms of y. Instead of function notation, it would be y equals log base b of x. And if I put that into exponent form instead of log form, I've got a base b, exponent of y, and an argument of x. If I put in a 0, any b to the 0 power is always 1. Anything to the 0 power is 1. So if y is 0, x is always 1. So that point right there, 1, 0, is definitely going to be on this graph. And as it goes down this way, it's going to hug the y-axis. And this is where we'll be less precise with this one. It goes off in that direction. It's very important that we become familiar with each of these types of functions, their equations, and their graphs as we go forward throughout this unit and farther in this in pre-calculus.